In this section, we're going to discuss linear models, or in other words, applying linear functions to word problems. Let's say the junior class is doing a fundraiser, and they pay $200 to rent an ice skating rink. In order to raise money, they charge students, we'll say $5 a ticket. So part one. Let's write a linear equation expressing the net income as a function of the number of tickets sold. So again, we're going to write a linear equation with net income, as a function of tickets. So this should be pretty straightforward, and that is $5 a ticket, and then you subtract the cost. So there's the cost, there's the income. So that should give us a net income, which I'll call I of X. Next question. What can X be? So what is the domain of X? The domain of X has to be positive because we can't have negative tickets. And secondly, it would be integer values only because we can't have half a ticket. So these would be all integers greater than or equal to 0. Saying that, what could Y be equal to? Y could be equal to all multiples of 5 that are greater than or equal to negative 200. Because negative 200, if you don't sell any tickets, you get negative 200. Then it could be negative 195, negative 190, negative 185, counting up until whatever the constraint would be in terms of number of people who could attend. Number 3. Well, to find the zeros of the function, I want to find the zeros of the function. This is a new term for you. The zeros are simple. It is when the function equals 0. So when does 5x minus 200 equals 0? When x equals 40. This is the break-even point. Or in other words, the point where you sold enough tickets to cover the expenses. The next question is, how much money will your class earn if 60 tickets are sold? So say we sell 60 tickets. How much money will you earn? So we plug in 60 for x, and we get $100. So I use this example not because it's difficult, but just to review some terminology. So here's our terminology for this section. Number 1, a function. Functions are discussed actually later in this year, but you should have a good understanding of what it is. It is a relationship between two variables, and obviously we use x and y, where for each x there is no more than one y. And just the notation that we use is f of x, g of x, h of x, and so forth. And remember, these are really just a replacement of y. The reason we use it for different reasons, but this basically says that x is the independent variable, and we can plug it into the function f to get the dependent variable y. The domain. Domain is all possible x values, as shown above in the above example. And the range is all possible y values. The last term for this section is zeros of a function. And as I said earlier, zeros refers to the x-intercepts. Another word for these is roots. We'll use that term a lot this year as well. So this is the end of this section. This should prepare you to do section 4 of the summer assignment.